We good? All right, we are live. Okay, so today we're going to talk about dividing polynomials. So the remainder theorem. What is the remainder theorem? It's actually kind of important because these two theorems go together, okay? Theorem, we didn't really do a lot of theorems in geometry just because that's the way we teach geometry, but theorem is just a math rule. The word theorem is just a math rule. And more specifically, it's a math rule that can be proven, okay? So if, that guy right up there, Einstein, he did a lot of proofs to prove his theories, right? So, and he did it all by math and math rules, okay? So the remainder theorem says this. So if P of x is divided by x minus c, okay, then P of c is the remainder. Okay, what does that mean? Let me show you. So on example 1, I'm going to actually do that, okay? So in example 1, we're going to divide my polynomial by x minus 3. So in this case, c is 3, okay? Because it says x minus c. In this case, c is 3. Does that make sense? So in my remainder theorem, if I'm dividing by x minus c, then in this case, my c is positive 3 because it says x minus 3, okay? So if I plug that in and go p of 3, we're left with 2 times 3 to the 4th minus 15x, whoops, times 3 squared minus 10 times 3 plus 5. Okay, now there's a really important reason we want to learn this, okay? But let me get you there, okay? For right now, it just says let's just plug in this number and we'll get the remainder, okay? So if I do that, hold on, so I'm going to plug it in, use my calculator, times 3 to the 4th minus 15 times 3 squared minus 10 times 3 plus 5, right? So I get an answer, 2, okay? So my answer is 2, okay? So, all right. So we're going to put R is 2. Now that's the remainder. Remember back in like 6th grade when you started learning how to divide, or 4th grade? 4th grade, right? And you put remainder, right? So the remainder is 2. So when we do divide this, we're going to get a remainder of 2. And we're going to divide this in just a bit, okay? So now what's the factor theorem? Well, factor theorem is easy, okay? Think about this. Okay? Spencer, give me a factor of 20.
4.
Perfect. Why did you say 4? 4's right. Why did you say 4?
4 times 5.
Goes in evenly, and there's no remainder, right? Okay, right? Does that make sense? Okay, Chloe, give me a factor of 50.
100?
No, 100 wouldn't go into 50.
Okay,
But what goes into 50?
Now I just looked dumb.
No, that's okay. Don't worry about it. So give me a factor of 50. What goes into 50? What goes into 50?
25?
Sure. No, you're totally right. Why did you say 25?
Because 25 and 25 is 50.
It goes in evenly, doesn't it?
Yeah.
So that you get a remainder of zeros, right? Does that make sense? You get a remainder of 0. So what is the remainder theorem? So the factor theorem says this. If x minus c has a remainder of 0, then x minus c is a factor. Okay, it's a factor. It goes in evenly. Remainder 0, right? Does that make sense? So, write that down. Even though we haven't divided example 1 yet, there's some things we know, okay? We haven't done it yet. There's some things we know. Is x minus 3 a factor? No. How do you know that? You're right, Spencer. How do you know it's not a factor?
Because R is not equal to 0.
Perfect. That's it. I mean, my God, you guys are making my job easy. That's it. How hard can that be, right? So all these big words just mean that. If you get a remainder of 0, it's a factor. It goes in evenly. Okay, I'm going to say it again. If it goes in evenly, you get a remainder of 0. It's a factor. What's a factor? Something times something makes something, but there's no remainder, right? Easy. Okay, now let's divide. Okay, here comes the hard part. But we can do this. So we're going to take x minus 3 and 2. 2x to the fourth plus 0x cubed minus 15x squared minus 10x plus 5. Okay? Now I'm going to show you a number that's going to make this obvious. Okay? I'm going to put a number off to the side. Just my little side note here. Little side note, when you're ready. This is so obvious. Why is math so hard for kids when it seems so easy, huh? This is just obvious. Okay, are these the same number? Are these two the same number? Please say no. What makes them different? The 0. So you have to have a place value for the hundredths, right? You have to have a place value for the x cubes. Hopefully that makes sense, right? Okay, next the fourth. I do not have an x cubed, but I have to have a place value for the x cubes, okay? So if you are missing a term, fill it in. Okay, let's divide. All right, here we go. I like to use different colors to do this. It's up to you, but it really helps me to use different colors. All right, so x goes into 2x to the fourth. X goes into 2x to the fourth. Well, if you have to divide, sometimes kids have to divide them. Do a little mini divide on the side. Hopefully you see that becomes a 2x. Where's my color? I'm looking for a color. Here we go. Hopefully you see that becomes a 2x to the third. You guys agree? X goes into 2x to the fourth. Now I'm not using the 3 yet, so just take the first term into the first term, okay? So now I'm going to multiply. I need to go this times this and this times this. Let's see, where's my pencil? My pencil could be erased. Pencil. I seem to never have a pencil because everybody's always borrowing my pencils. But anyway, might have one. Hidden away. Oh, I don't know. We'll see. So I multiply. Ready? I'm going to get a 2x to the fourth. Minus a 6x to the third. Okay, long division. So first I said x goes into 2x to the fourth how many times? X goes into 2x to the fourth this many times, right? And then I multiplied that times that times that, okay? And now I'm going to subtract. So when I subtract, I got to be careful because I'm subtracting both, right? Just like long division. So what I do to make it so I don't make dumb mistakes, I just change the signs. You okay with that? Minus a minus. Okay with minus a minus? And then instead of subtracting, I just add. So that cancels, and I'm left with a 6x to the third. Okay, this is just long division, just like in 4th grade. Bring down the next term, right? So we're going to bring down the next term, okay? So bring down the next term. And I'm going to get a negative 15x squared, okay? Let's divide again. So the same thing, just like long division. Just like long division, x goes into x to the third. And if you can't do that in head, you can always do a little bit of you can always do some side work. Okay, so 6x cubed divided by x. Hopefully you'll say, oh, Mr. Davies, that's 6x squared, right? So x goes into 6x cubed, 6x squared times, so positive 6x squared. Put the positive. Okay, and then we'll do the same thing. We'll multiply. We'll go that times that times that. Am I going too fast? So I brought down my 15, and then again I'm dividing. X goes into 6x cubed. How many times is 6x squared? Now I'm going to multiply. I'm going to get a positive 6x cubed and a negative 18x squared. Okay? I'm subtracting, right? But I get messed up when I do double negative, so I just bring the negative through. That one goes into there, makes it a plus, right? And then I basically subtract. So these two cancel. And then I'm left with a 3x squared Okay, how am I doing? And then, we're bringing down the next term, negative 10x. Right? And then I'm going to, again, divide. Okay, so then I'm going to go, okay, well, x goes into 3x squared times, right? This, how many times does it go into it? Again, if you want to divide on the side, you can, but it should go in 3x times, okay? So 3x squared divided by x is just 3x. So I'm going to put a positive 3x up here. And again, I've got to multiply. Just like long division, I've got to go that times that, which is going to give me a 3x squared minus a 30x. Nope, minus a 9x. Come on, minus a 9x. Come on, I can multiply. Again, we're subtracting, right? So subtract. Me, personally, I always get messed up with double negatives, so I just bring it through, make that a plus, right? And then when I subtract, these two cancel. That makes a negative 1x. And we'll do this all over again, one more time, just long division. X goes into a negative 1x. Right? X goes to negative 1x, hopefully negative 1 times. You guys agree with negative 1? X divided by this is a negative 1. So I'll put my negative 1 in here. And then I'll multiply. Okay, so I'll go this times this, gives me a negative 1x minus 4. Now I got to bring down my 5, right? And did I make a mistake somewhere? Oh, good. Yes, 3. I did make a mistake. I knew I made a mistake. You know why I knew I made a mistake? Right there. Right? Remember I told you it'd be the remainder? And then, when I subtract, I'm going to get a 2 as my remainder, and that's exactly what I said it would be. Now the answer, though, what's the answer? Here it is. Here's my answer. My answer is, just like division, it's a 2x cubed plus 6x squared plus 3x minus 1. And then, what do we do with the 2? We're not going to go remainder 2. That was 4th grade math. What did you do in 5th grade? You made it into a fraction. So you're going to say plus 2 over what we divided by, which was the x minus 3. Okay, the remainder. You can't say remainder. It is really 2 left over out of my x minus 3. Okay? All right, now, that was hard, wasn't it? Lots of places to make a mistake. Now, here's the deal. There's an easy way to do this, and I'm going to show that to you in just a moment, okay? The trick I'm going to show you only works if it's x plus or minus some number, okay? So turn the page. We did this last year, but of course nobody remembers anything from last year, okay? Synthetic division is so much easier, but it only works on some, only works if it's x plus or minus some number. Only works if it's just a regular x. Synthetic division only works if it's a regular number. In this case it is, x minus 3, okay? We did this last year. Let's see if you remember. So synthetic division is like upside down. Upside down division. So I'm going to start with an upside down division symbol, okay? So when I do synthetic division, the x's become invisible. We know they're there, but they're invisible, okay? So I'm going to go 2, 0, right? Right. Negative 15, negative 10, and 5. Okay, the x's are invisible, right? When I divide, I'm going to, instead of subtracting, we're going to add the opposite. Because if you add a negative, you're subtracting. So we add the opposite. So I'm going to put a positive 3 here, okay? Positive 3. I'll even put a positive there. So I don't need the positive, but I'll put it there just so you see it, okay? I want to emphasize the opposite. Always the opposite. So this is negative 3. It's positive 3, okay? I call this my, and thank goodness I don't teach English, I call this my here, my adder line. My adder line. I know there's no such word as adder, but we're going to call it my adder line. Okay, this is my add line. Because we don't subtract, we're adding a negative, okay? Now, everybody good on this? So here's how you set it up. You put your coefficients in, 2, 0. Everybody okay with where the 0 came from, right? Negative 15, negative 10, 5. And I put the opposite there, okay? So here's how it starts. Step 1. Step 1. Bring the first term straight down. I like to do it inside the adder line so I don't forget that I'm not going to add anything in here. Just bring it straight down. Bring down the 2. Step 1, bring the 2 down, okay? And then we're going to multiply. We're going to multiply. Two times 3 is 6. Put the 6 right there. And then it's my adder line, right? So I add. 0 plus 6 is 6. And then I multiply. I get an 18. It's my adder line, so I add. I get a 3. And then I multiply. Okay? 3 times 3 is 9. Am I going too fast? Okay, then I add, and I get a negative 1. And multiply. Negative 3. And then I like to use a little box here. That's my remainder box. There's my 2. There's my answer, except for, wait. Except for the x's were invisible, right? So let's put the x's back. So since we did divide by x, we're going to have 1 less degree. So it originally was next to the 4th, right? So this is going to be a 2x to the 3rd plus 6x squared plus 3x minus 1. And what do we do with the 2? Plus 2 over what we divided by, and what we divided by was the x minus 3. Originally, that was the original problem, right? By the x minus 3. Okay, there's my answer. That was a lot easier than that. Do you agree? A lot easier. But it only works if it's x plus or minus some number, okay? All right, now, the remainder. Well, we know the remainder is 2, right? So then there's this thing called synthetic substitution, which we already did on the front page. Synthetic substitution says if you plug in 2, you'll get the remainder. So now we could, but we're not going to. We could take, 2x to the 4th minus 15x squared minus 10x plus 5. And we could divide this by x minus 2. We could, but to get the remainder. I don't want to. So instead, if all we need is the remainder, that's all I need. All I need is the remainder on this one. Let's plug in 2. Okay. So if I go p of 2, I'm going to go 2 times 2 to the 4th power minus 15 times 2 squared minus 10 times 2 plus 5. And I'll get the remainder if I divided it. But I'm not going to divide it. I just want the remainder, right? Okay, so let's see. 2 times 2 to the 4th minus 15 times 2 minus 10 times 2 plus 5. I need an answer of negative 13. I must have made a mistake. Yep, I did. I see my mistake. I did. I made a mistake. I forgot to square it. 2 to the 4th minus 15 times 2 squared. There was my mistake. Minus 10 times 2 plus 5. I thought this one came out to be a 0. Well, shoot. I'm going to have to fix my worksheet for next year. So I got an answer, p of 2 equals negative 43. Okay? I was hoping for a 0. Because if it was 0, you could say that it is a factor, but it wasn't. Okay? So if p of c equals 0, we know that x minus c is a factor. And I did not do that. Doggone, I got to fix it so it goes in evenly. Shoot. Okay, anyway, that's what I have. Homework today, and I'll help get you set up, okay? Page 61, 1, 3, 6, 7. And this does definitely take some work. No work, no credit. You guys agree with that?